Okay, so the next thing I want to talk about is growing annuities. Now, when we talk about annuity, we all know that it is a payment or receipt which is made periodically. All right. So, like maybe you are receiving 5,000 CDs every year for the next 5 years, or 5,000 CDs every year for the next 2 years or 3 years, whatever. That's an annuity. Now, the question we must ask ourselves is that let's assume that you opened an account and every year you are depositing, let's say, 1,000 CDs into that account every year. You are depositing 1,000 CDs into that account. However, you have decided that even though you are depositing 1,000 CDs in that account, every year you increase that 1,000 CDs by 5%. So here, even though it is an annuity, that annuity is growing, okay? That annuity is growing. So even though it is an annuity, that annuity is what? Growing. It is growing every year, okay? Now, the question we must ask ourselves, therefore, is that if your annuity is growing, how do we find present value? And this one is pure formula work. So, we are going to talk about present value of a growing annuity. So, the present value of a growing annuity, the formula is simply the payment into brackets 1 minus 1 plus J all over 1 plus R raised to the power N all over R minus J. So this is the formula of present value of an annuity that is growing. So in this formula, we all know the element except J. J is the growth rate. J is the growth rate. So let's take the example in the slides. The example in the slide says that suppose your kid is 12 years today and you wish to set aside 300 CDs for her every year until she turns 18. So she is 12 years and you want to set aside 300 CDs every year until she turns 18. So the difference is 6 years. 6 years. The difference is 6 years. So here, depositing 300 CDs every year makes the thing an annuity, technically. 300 CDs for her every year. Every year there makes it an annuity until she turns 18. Now look at the growing annuity aspect. It says that suppose you commit to increasing the subsequent deposit by 5%. So here, the growth rate is 5%. If you save with a bank that pays 12% on deposit, how much is your promise worth today? How much is your promise worth today? So we are looking for present value. Okay, and what are we talking about? We are talking about present value of a growing perpetuity. Sorry, growing annuity, sorry. So the number of years is 6 because she is 12 today and you want to give her, you want to set aside 300 every year until she turns 18. So the number of years is 6. The amount itself is 300. The growth rate is 5%. And the interest rate is 12%. So when you have a question, you just write out the key things so that you don't confuse yourself. So, as I said, the payment or the amount is 300. Number of years is 6. Interest rate is 12%. The growth rate is 5%. So putting it here, we have 300 multiplying by 1 minus 1 plus 0.05 all over 1 plus 0.12 raised to the power 6 all over 0.12, sorry, minus 0.05. Good. So we have 300. 1 minus 1 plus, so 1 plus 0.05 is 1.05. Then 1 plus 0.12 is 1.12 raised to the power 6. So 0.12 minus 0.05 is 0.07. So that you have to, you see, I know some of you can punch everything on calculator straightforward. But sometimes it's good to take your time, okay? Very, very good to take your time. So now we have 300 into brackets, 1 minus, so you can punch everything here, as in 1.05 divided by 1.12 raised to the power 6. So it's 0.6789. So 1 minus 0.6789 divided by 0.07. So everything in the brackets, so everything in the bracket here, when I point my eye, had 4.5871. Please let's just confirm the answers. Yeah, all of us have a calculator, so let's just confirm the answer. Let's just confirm. I had the final answer to be this. So as for the formulas there, if you are wondering, we'll give you a formula sheet. The answer is no. You must know the formulas off head. You must know present value of ordinary annuity, growing annuity, and stuff, all those things. Okay. Somebody's asking, is the growth happening at the end of? Yes. It's like the money you are depositing. Okay, not is the money you are depositing every year that is going to grow. That's it. Not that you've left the money to grow. It's like I'm depositing 300 cedis every year. All right. But then this 300 cedis is going to grow by 5%. So it means that the first will be 300, the second will be 315 because the 300 will grow by 5%. So 315. All right. The third will be 330.75. The fourth will be 347. So it's like the 300 deposit you are making. You yourself, you are increasing that deposit by 15%, sorry, by 5% every year. Okay. So the annuity payment you are making, you are increasing that payment every year by 5%. That is what we are doing. All right. So an annuity payment or receipt you are making, but that payment or receipt itself, you are increasing it. Like you are increasing the payment by a certain growth rate. So that's what we are doing. All right. Okay. Now, before we go to perpetuity, there is something that I need to share. Okay, it's not in the slides, but I just need to share. Now, the concept of annuity due. Annuity due is when payments or receipts are made at the beginning of the period. An ordinary annuity, which we've done already, ordinary annuity is when payments or receipts are made at the end of every period. So I said that present value of ordinary annuity, if you remember, I said is payment into brackets 1 minus 1 plus r raised to the power minus n all over r. Then future value of ordinary annuity is payment into bracket 1 plus r raised to the power n minus 1 all over r. Good. So if a question is silent, we always assume ordinary annuity. Because ordinarily, payment or receipt are made at the end of a period. But if the question says that the payment or receipts were made at the beginning of a period, we call it annuity due. Annuity due. So present value of annuity due is payment into bracket 1 minus 1 plus r raised to the power minus n times 1 plus r. And then present value of, future value of annuity due is payment into bracket 1 plus r raised to the power n minus 1 all over r, 1 plus r. You multiply it. So the difference between the due formulas and then the ordinary formulas is that you multiply the ordinary formulas by 1 plus r again. So you just multiply everything by 1 plus r. Write down the formulas and let me take an example on this so that you understand it better. So let's write down the formulas. You take an example and I'm sure it will be clear to you. We will take an example and I'm sure it will be clear to you. Okay. So let's take an example. Assuming you won a lottery, that will pay you 500 cedis each year. For the next 7 years. Somebody says writing the formula. Don't worry. When we are solving the question, I'll let you write again. Don't worry. What is the present and future values of this payment if interest rate is 10%? Now the question says that the thing, it says 500 each year, okay? 500 each year. 500 each year. The question didn't say whether you are receiving it or you are paying it. Sorry, whether you are receiving the money at the beginning of the year or at the end of the year. So when a question is silent like this, the default assumption we make is ordinary annuity. Ordinary. 500 each year. Each year makes the thing an annuity, but the question is whether at the beginning of the year or at the end of the year. So the default we assume is what? Ordinary annuity. So we want to find present value of ordinary annuity. We all know the formula. Payment into bracket 1 plus, sorry. 1 minus 1 plus r raised to the power n all over r. So we have 500 into brackets 1 minus 1 plus 0.1 raised to the power 7 all over 0.1. For me, I'm going to read my table. 10%, 7 years. I'm going to read present value interest factor of annuity table. %, 7 years. Here, present value interest factor of annuity. 4.8684. 4.8684. 4.8684. And the question says, find the future value of these payments. No, I said 7 years. I didn't say 6 years. Oh, I said 7 years. No, please. We are done with. Let me show you. I don't know those of you joined late. We are done with growing annuities. We are done with that question. We are now talking about annuity due. Okay, annuity due is a different thing. So that's why I gave you my own question. Okay, all right. Sorry, negative n here. Somebody drew my attention. So when you punch everything in the bracket, you get this. All right. This thing you are used to. I mean, this one we did it even before growing annuities. Then future value of ordinary annuity. The formula is payment into bracket 1 plus r raised to the power n minus 1 all over r. So you want to find the future values of the 500 each year. To be 500 into bracket 1 plus 0.1 raised to the power 7 minus 1 all over 0.1. Okay. You can simply read your table or you can punch. This one, the punching is easier. But you can read your table. The future value, because you are talking about future value, so you can read future value interest factor of annuity. Okay, 10%, 7 years. 10%, 7 years here. That means I'm not punching something right, because what? Future value interest factor, 10%, 7 years is 9 point something. What did I get? Let me see. I'm not punching something right. I don't know. Yeah, I think I didn't point it right. Oh, these things, we've done them before. I mean, before we went for break. I'm just adding the annuity due, all right? So let's say that what will be your answer? If the payments are received at the beginning of each year. So I'm saying that whenever a question is silent, we assume what? Ordinary annuity, ordinary annuity. If the question wants you to do annuity, the question will say something like this. When the payments are received at the beginning of a period, it makes it due. But if the question is silent, even if the question doesn't say at the end of the period and the question is simply silent, if the question is simply silent, we assume ordinary annuity. So if the payments are made at the beginning, it becomes present value of annuity due, which is payment into brackets 1 minus 1 plus r raised to the power minus n all over r. Then multiply it again by 1 plus r. So if the payments are made at the beginning, that's what is going to happen. So I don't want to write everything again. We've already done this first part. Then you multiply by 1 plus, the interest rate was 10%. Yeah, that's all. The future value of annuity due. Multiply by 1 plus r. So here also, 9. Okay. So in sum, these are the things we've learned on annuities. Annuities. Present value of ordinary annuity, present value of annuity due, present value of a growing annuity, future value of ordinary annuity, future value of annuity due. These are the 5 things we've learned on annuities. These are the 5 things you've learned on annuities. In summary, these are the 5 things we've learned on annuities. Okay. Now, let's go to perpetuities. Remember, I told you that perpetuity is when we are receiving or paying something every period, but it is forever. Okay, perpetuity does not have a terminal point. Perpetuities is forever. So let's look at this example. Suppose you have the opportunity to invest in a venture that will pay you, let me see. Somebody's asking, is there a formula for future? Yes, there is future value of growing annuity, but let's not enter into that, okay? Your syllabus limits us to this, so let's do it. There is, but let's limit ourselves to this. Okay. To invest in a venture that will pay you 600 next year, and it will increase every year indefinitely. How much will you pay for it if similar opportunities offer 12%? Now, this question, I told you that when it comes to perpetuities, we can't find future value of perpetuity. We can't. Reason being that perpetuity is indefinite, it's forever. So the only thing we can find is what present value, because we don't know the terminal point. So how can we find the future value? So if the perpetuity was not growing by 5% every year, the present value of the perpetuity would have been the amount divided by R, and it would have been 600 divided by the interest rate is 12%, so 0.12. Assuming it wasn't growing, assuming the perpetuity was not growing, then the answer will be 5,000. But if the perpetuity is growing by 5% every year, the formula for growing perpetuity is amount over R minus J. That is the formula for a growing perpetuity. Amount over R minus J, where J is the growth rate. So we have 600 over 0.12 minus the growth rate of 5%, so 0.05. $8571.43. And these are the simple things you'll be seeing in exams. Like they are straightforward. Just know what formula to apply at what time. So this question is actually a growth perpetuity. Assuming the question didn't have a growth rate, the thing is not increasing every year, like it's just stable, then we would have solved it like the first one. Okay, but since it has a growth rate of 5%, we need to adjust the formula with the growth rate. Then we have this, all right? So as part of your formula sheet, you can add that present value of perpetuity is the cash over R, or you can say amount over R. And then present value of growing perpetuity is the amount over R minus J. That's all. Just add it to your formula sheet. Your list of formulas.